In this unit, we'll talk about the reasons for choosing TiDB, as well as showing some of the TiDB users. Many customers choose TiDB due to these two reasons. The first one is scalable. TiDB is scalable for mission-critical workloads. TiDB provides horizontal scalability, meaning that TiDB supports zero downtime scaling in and scaling out at every sub-component layer, which includes the computational layer, the storage layer, and the metadata layer. These layers are decoupled from each other and can be scaled on demand without any disruptions. By using TiDB, you may eliminate both planned and unplanned downtime. In addition to the scaling in and scaling out mentioned before, TiDB also supports online rolling updates and online DDL. Its built-in self-healing ability is enabled at the compute, storage, and the metadata layers, ensuring that business continuity when faced with software failures, hardware malfunctions, and even data center outages. In addition, users can enjoy these benefits on TiDB Cloud with no additional setup. Similar to traditional RDBMS, TiDB offers full ACID transaction support with strong consistency. TiDB is compatible with MySQL 5.7, meaning that in most cases you can migrate your existing applications to TiDB without the need to alter the application code. It has already been proven in production that consolidating hundreds or even thousands of MySQL-compatible databases into a single TiDB cluster is possible. The second reason for choosing TiDB is its built-in translatable or HTAP capability, meaning TiDB is able to deal with the transactional and analytical transactions at the same time. TiDB is equipped with both role-based and column-based storage engines, making it optimized for handling both OLTP and analytical workloads simultaneously. With a single standard SQL interface, business analysts can easily gain insights from both online operations and code data combined. TiDB is able to efficiently store and retrieve a large amount of data at the PB scale. TiDB simplifies the handling most big data issues with its implementation of the standard SQL and with the added support for JSON data type and functions. It eliminates the need to incorporate specialized tools from the big data ecosystem. As a result, SQL is back in the driver's seats. TiDB encapsulates the complexity of no one-size-fits-all and reduces the reinvestment, especially in the reinvestment in the cloud. In the field of database, it has been widely accepted for many years that there is no universal solution that fits all, since varying applications have their unique database requirements. While some require high availability and scalability, others demand high performance and low latency. Furthermore, different database technologies and configurations offer distinct advantages and limitations. Thus, it is essential to comprehend the specific needs of your application and select the appropriate database technology and configure that optimally address those requirements. However, this often leads to a significant increase in the management complexity, which can be further amplified in the public cloud environments because of the reinvestment issue. At TiDB's core, it is a key-value non-SQL database that incorporates a stateless SQL layer, granting it the advantages of both non-SQL and relational database management systems. It has been designed to handle the complexities associated with combining these two technologies, adhering to the principles of no one-size-fits-all at a lower level. However, at the higher operation level, TiDB presents a single management interface as a unified database, enabling users to benefit from both approaches simultaneously. Unless your application requires extremely low latency, otherwise, for most of the cases, TiDB is a comprehensive solution. As mentioned earlier, TiDB offers both role-based and column-based storage engines. The column-based storage engine is capable of automatically replicating the necessary data from the role-based storage engine for analytical workloads without the need for additional ETL jobs. Here goes an example architecture without TiDB. We placed 6 database clients instances here. In the practice, of course, there could be much more. The architecture is already cloud-friendly. The availability zone here stands for the data centers, or AZ, provided by cloud service providers. And we have MySQL for online transaction processing. The standby database here is a full replica of the leader database for high availability and disaster recovery purposes. With the leader for writes and read replica for reads, you can handle a pretty serious workload. And there is a cache for transact objects or hotspot objects to improve the read performance. NoSQL database here is a horizontal scalable persistent store, and its nodes can span across the availability zones to achieve the requirements of high availability, disaster recovery, performance, and data growth at scale. The data layer architecture is complicated to some extent. Let's zoom in MySQL master. As the business grows, the data will eventually outgrow the single machine. One way of handling the increase in writes is to split the data over multiple databases using what's called sharding. For example, to begin with, you might store all information for users with the user ID starting with the letter A through Z in a single database. To increase the write capacity, you split the database into two. Well, some users are handled in the first database and some in the second. Here, we use the first letter of the user ID as an example, but in practice, people sometimes use consistent hash to determine a shard used for a specific piece of data. When you need to increase capacity further, you do the same thing and split dataset again. Adding shard means that generating reports gets more and more difficult. Those are only for write operations. You also need replicas in local availability zone for read performance and standby database per shard in the peering AZ for high availability and disaster recovery. This is no fun at all for the developers and ops team. By using TiDB, the data layer architecture is straightforward and the exposed complexity is dramatically mitigated. Like NoSQL, TiDB is distributed and is capable of a horizontal scaling. TiDB handles sharding automatically and it's transparent to your application. Unlike NoSQL, TiDB supports transaction and SQL in native and is compatible with MySQL. Within TiDB, the replication happens automatically, the sharding happens automatically, the role-based and column store transformation happens automatically. It acts in a position as a multiple-purpose database to replace MySQL and a NoSQL database simultaneously. TiDB is versatile, so you can focus on your application. Users acquire data agility without worrying about the future of growing pain. But I have to mention that even TiDB is versatile, it cannot eliminate the hotspot bottleneck caused by your application. So, cache components like Redis are still required for the application hotspot cases. We will discuss how to mitigate hotspot in detail in the TiDB performance tuning course in the database operation learning path and TiDB specific feature course in developer learning path. TiDB is used by more than 3,000 global adopters and it is trusted by global innovation leaders. Here are a few examples. Catalyst is a software as a service company that provides a powerful customer success platform to help the companies achieve success with their customers. Catalyst used PostgreSQL and then Elasticsearch for their data backends, but it did not work out. Then, Catalyst investigated TiDB. They found that TiDB's response time was 10 to 60 times faster than its competitors. Also, they are keen that TiDB has perfect support for online DDL. Bolt is a global mobility company headquartered in Estonia that mainly offers vehicle hailing, car sharing, and food delivery service. Bolt has more than 100 million customers. Previously, Bolt used MySQL as its main database. As the data volume grows, sharding was introduced and did not meet their expectations. Bolt explored Vitis and TiDB for the MySQL replacement. It turned out that Vitis required too many changes to the Bolt's application. Bolt finally chose TiDB, an open source distributed NoSQL database. Bolt is impressed by TiDB's almost infinite horizontal scalability. By automatically adding or removing storage nodes, it can easily handle up to hundreds of terabytes of sudden data spikes or plunges. Moreover, TiDB has strong compression capability, which reduces the storage cost. Lastly, it has a simplified architecture and can handle transactional and analytical workloads at the same time. For more information, you may go to pincap.com/customers for more use cases.